For a 45-foot run supplying a 100 amp single-phase 120/240 volt commercial subpanel, copper is generally the preferred choice over aluminum for several reasons. Firstly, copper has a lower electrical resistance than aluminum. This lower resistance translates to less voltage drop and energy loss over the length of the run. While electricity flows through a conductor, some energy is dissipated as heat due to the resistance of the material. A lower resistance means less energy wasted as heat, making copper more efficient, especially for longer runs. Secondly, copper boasts a higher current carrying capacity compared to aluminum for the same wire gauge. The current carrying capacity, often referred to as ampacity, is the maximum amount of electrical current a conductor can safely carry without exceeding its temperature rating. Because copper can handle more current for a given size, you can often use a smaller gauge copper wire compared to aluminum for the same application. This can save space and potentially reduce installation costs, although copper is typically more expensive per foot than aluminum. Thirdly, copper offers superior heat dissipation compared to aluminum. When electrical current flows through a conductor, it generates heat due to the conductor's resistance. If this heat is not dissipated effectively, the conductor's temperature can rise, potentially damaging the insulation and creating a fire hazard. Copper's higher thermal conductivity allows it to dissipate heat more readily, keeping the conductor cooler and safer. While aluminum is lighter and generally less expensive than copper, its higher resistance and lower current carrying capacity make it less suitable for longer runs in demanding applications such as feeding a subpanel. Using aluminum in such scenarios can lead to increased energy losses, voltage drop, and potential overheating issues if not properly sized and installed. When selecting conductors for electrical installations, it's crucial to consult the National Electrical Code, or NEC, and local electrical codes to ensure compliance with all applicable regulations. The NEC provides detailed guidelines on conductor sizing, opacity, installation methods, and other important factors that affect the safety and performance of electrical systems. When using aluminum conductors, it's particularly important to use properly rated connectors and termination methods specifically designed for aluminum to prevent corrosion and ensure a reliable connection. Aluminum forms an oxide layer on its surface when exposed to air, and this oxide layer can create resistance and lead to connection failures if not properly addressed. In summary, while aluminum can be a viable option for some electrical applications, copper is generally the preferred choice for feeding a subpanel, especially in commercial settings where reliability and efficiency are paramount. Its low resistance, high current carrying capacity, and better heat dissipation make it a safer and more reliable option for longer runs and demanding loads. Remember to always consult with a qualified electrician and adhere to all applicable electrical codes and regulations when installing or modifying electrical systems. For instance, NEC Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. This table is crucial when determining the appropriate wire size for a given application, ensuring that the conductor can safely carry the intended current without overheating. For example, a copper conductor with a temperature rating of 75 degrees Celsius and a size of 3 AWG has an ampacity of 100 amps, while an aluminum conductor of the same size and temperature rating has an ampacity of only 85 amps. This difference in ampacity highlights the superior current carrying capacity of copper compared to aluminum. Another important consideration when selecting conductors is the voltage drop over the length of the run. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction, reduce the efficiency of lighting systems, and even damage sensitive electronic devices. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's essential to choose conductors that are appropriately sized for the length of the run and the amount of current being carried. Copper's lower resistance makes it less susceptible to voltage drop compared to aluminum, making it a better choice for longer runs where voltage drop is a concern. When working with electrical systems, always prioritize safety and follow all applicable codes and regulations. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. The electrical work can be dangerous, and improper installation can lead to serious injury or even death. Consider a scenario where you need to run a 100 amp feeder to a subpanel located 45 feet away. Using copper conductors, you might be able to use a smaller gauge wire compared to aluminum, which can save space and reduce installation costs. For example, you might be able to use 3 AWG copper conductors instead of 1 AWG aluminum conductors, depending on the specific application and the ampacity ratings of the conductors. The smaller size of the copper conductors can make them easier to work with and can reduce the overall cost of the installation. In addition to the factors already mentioned, another important consideration when selecting conductors is the type of insulation used. Different types of insulation have different temperature ratings, and it's essential to choose insulation that is appropriate for the environment in which the conductors will be installed. For example, conductors that will be installed in a hot environment may require insulation with a high temperature rating to prevent the insulation from breaking down and causing a short circuit. Common types of insulation include THHN, THWN, and XHHW. THHN insulation is a thermoplastic high heat resistant nylon coated insulation that is commonly used for general purpose wiring. THWN insulation is a thermoplastic high water resistant nylon coated insulation that is suitable for use in wet locations. XHHW insulation is a cross-linked polyethylene high-heat water-resistant insulation that is commonly used for underground wiring. When selecting conductors, it's also important to consider the type of equipment that will be connected to the subpanel. Some types of equipment, such as motors and transformers, can draw large amounts of current when they start up. This inrush current can cause voltage drop and can even damage the conductors if they are not properly sized. To prevent these problems, it's important to choose conductors that are sized to handle the inrush current of the equipment that will be connected to the subpanel. The NEC provides guidelines on how to size conductors for motor circuits and other types of equipment that draw large amounts of current. Another important consideration is the grounding system. A properly installed grounding system is essential for protecting people and equipment from electrical shock. The grounding system provides a low impedance path for fault current to flow back to the source, which causes the circuit breaker to trip and de-energize the circuit. The NEC requires that all electrical systems be properly grounded, and it provides detailed guidelines on how to install a grounding system. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the grounding electrode to the electrical panel. The grounding conductor must be sized according to the NEC, and it must be properly installed to ensure a reliable connection. In addition to the grounding system, it's also important to install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect ground faults and to quickly energize the circuit, preventing electrical shock. The NEC requires that GFCIs be installed in all new construction and in many existing buildings. When working with electrical systems, it's important to use the proper tools and equipment. This includes insulated screwdrivers, pliers, and wire strippers, as well as a voltage tester to verify that the circuit is energized before working on it. It's also important to wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical shock and other hazards. Before starting any electrical work, it's important to obtain the necessary permits and to notify the local utility company. The utility company may need to disconnect power to the building while the work is being performed, and it's important to coordinate with them to ensure that the work is done safely and efficiently. When the electrical work is complete, it's important to have it inspected by a qualified electrical inspector. The inspector will verify that the work was done according to code and that the electrical system is safe to operate. In summary, when selecting conductors for a 100 amp single-phase 120/240 volt subpanel with a 45-foot run, copper is generally the preferred choice over aluminum due to its low resistance, higher current carrying capacity, and better heat dissipation. However, it's important to consider all of the factors mentioned above, including the type of equipment that will be connected to the subpanel, the grounding system, and the applicable electrical codes and regulations. Always prioritize safety and consult with a qualified electrician when working with electrical systems. Remember, safety is paramount when working with electricity. Always double-check your work and ensure that all connections are tight and secure. Never work on live circuits, and always energize the circuit before starting any work. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. First, always ensure the power is off. Secondly, verify with a voltage tester. Thirdly, double-check the voltage tester is working by testing a known source. Then, finally, and only then, consider the circuit to be confirmed energized and safe to work on. One must have a healthy respect for electricity. Ignoring safety procedures or cutting corners can result in serious injury or death.